Is about morphosyntactic information of highly inflectional language in statistical machine translation when translated to or from a language with very simple morphological structure. It's commonly English. First, I will tell what is the motivation for our work. Then I will say some words about morphological feature of Slovenian language. Then I will describe what was the baseline translation system in our experiments. And then I will present 3 different ways of using morphosyntactic information in machine translation. The first one will be re-ranking the best list. The second one is factor translation model. And the third one is operation sequence model. Then I will show you some experimental results and conclude with some final remarks. So our core approach was phrase-based statistical machine translation, although neural networks appear as promising approach in machine translation recently, but we base our research on phrase-based statistical machine translation, where basic unit is data-driven phrase, and the best translation is produced by log linear model composed of different feature functions. Our experiments were performed on English-Slovenian language pair, where Slovenian present a highly inflectional language. It is a well-known challenge, translation into languages with rich morphology. Why? Because rich morphology causes data sparsity problem, and this could be solved by enlarging corpora, or as research shows, integrating some linguistic knowledge could also reduce data sparsity problem. There is a big difference between translation from inflectional language or translation to inflectional language. If we translate from inflectional language to, for example, English, some kind of morphology reduction is needed. And the opposite, if we translate to inflectional language from, for example, English, we need some kind of morphology generation. Let me say some words about language in our research. It is Slovenian language. It belongs to South Slavic family of languages. It's spoken by only approximately 2.5 million of speakers, mainly from Slovenia. It uses basic Latin alphabet with 3 additional letters, č, š, ž. It is highly inflectional language. For example, for a noun, we have 6 cases, 3 numbers, 3 genders, and noun can have 10 different declination forms. But Slovenian language shares its linguistic characteristic with many other Slavic languages. So how we use morphosyntactic information? We use a generalized representation of words, where to each surface form of a word, basic grammatical category is added. It is well-known part of speech information, where to a verb, the information is assigned if it is a verb, a noun, adjective, and so on. And then we use additional attributes with more detailed information about morphology. We call these attributes morphosyntactic descriptions, and they determine the gender, case, number, and so on. So in our experiments, we use 58 different texts for English. It is extended set from Penn-Treebeck project, although in our training corpus only 54 different texts appear. And for Slovenian, 1,903 texts were defined in the scope of Multex East project. And similar in our training corpus, only a bit more than 900 texts appear. We also do some experiments with reduced set of attributes in MSD text for Slovenian. Mainly, we keep the information about gender, number, and case, and person in verb and pronouns. This set of reduced attributes was intuitively chosen with no deep linguistic analysis. So these MSD tags were attached to the corpus by two different taggers. We use 3-tagger for English and Slovenian, and additionally obelix tagger. It is a Slovenian tagger with some language-specific rules integrated in the tagger. So what was our baseline system? In all our experiments, we used Slovenian English parallel corpus from Europar corpus version 7. It is a corpus of talks from European Parliament. In our case, it has 623,000 sentences and about 16 million words on English sites and 14 million words on Slovenian side. The corpus was true-cased and tokenized, and then standard Moses phrase-based statistical machine translation system was trained. For alignment, we use Giza++ tool, and after training Giza++, grow diagonal final and symmetrization was used, and in baseline system, we use word-based 3-gram language model with modified Knesser-Ney discounting. So resulting translation were detruecased and detokenized before evaluation. For evaluation, we use standard blur metric with no adaptation to inflectional feature of Slovenian language, for example. So what were these three approaches to include morphosyntactic information? The first one was re-ranking the best list. This is a two-pass decoding, where in the first pass, baseline system is used and produce the output containing n best hypothesis for each input sentence. And then in the second pass, some additional knowledge source is used to rescore this best list. In our case, this additional knowledge source was language model of MSD tags. So in our setup, we decided to use 1,000 hypotheses for each input sentence. We tag Slovenian hypothesis with obelix tagger, and then rescore the hypothesis with 6-gram language model of MSD tags. In the second set of experiments, we try factored translation models that were defined by Kuhn and Huang in 2007. The idea of factor translation is to operate on different factors instead of only on surface forms of words. In our case, we use 3 different factors: surface form, lemma, and MSD tag. So we try very different setups of these factor translation models. In the first set, we decided to use for translation in both directions, from English to Slovenian and from Slovenian to English, 2 different types of translation model. The first one is where on the source and on the target size surface form and MSD tags were used. This is this one. And in the second experiment, we add as additional factor lemma on both sides, on source and target. And from translation from English to Slovenian, we try also a system where on source size, on English size, only surface form was used, and on target size, surface form and MSD tag. And in the second experiment, still only surface form for English and surface form, MSD tag, and lemma on Slovenian side. For translation from Slovenian to English, we use lemmatized forms on Slovenian side and surface form on English side. And in the last experiment, lemma and MSD tag on Slovenian side and surface form and MSD tag on target size. The last experiment with morphosyntactic information was operation sequence model. It was defined by Durrani in 2011 and extended in 2014. It is a joint model for translation and long-distance reordering. As we all know, the baseline system is able to model only short-term or short-distance reorderings. So in operation sequence model, translation is linear sequence of operation, where an operation either generates source and target words or perform reordering by inserting gaps, jumping forward and backward. And operation sequence can be learned over different factors, not only over surface forms, but also over MSD tags or lemmas. So in our experiments, operation sequence models were trained over surface forms and added as such to the baseline system, and to the factor translation system based on surface forms and MSD tags. OSM models over MSD tags were added, and to the factor translation system based on surface form, MSD tags, and lemmas, OSM models over lemmas was also added. And here are some results that we obtained. In the first row is the result of baseline system. Re-ranking was performed only for translation direction from English to Slovenian. To remind you, in this case, we re-rank the hypothesis with MSD language model. And as you can see, only slight improvement was obtained in these experiments. In a second set of experiments, we experimented with different factored translations, where each configuration was run twice, first with 3-tagger and then with obelix tagger. In the first line, again, is the result of a baseline system. And as you can see, the best result was obtained with factor translation, where on English side only surface form was used, and surface form and MSD tag on a target side. And we can see that even obelix tagger is adapted to Slovenian language. The better results were obtained with 3-tagger. And we can see that with reduced tags in the last row, only slight drop in blue score was obtained. So, and here is the result for Slovenian to English translation. In the first row, again, is the baseline result. And in this case, we can see that the best result was obtained by using surface form and MSD tag on both sides, and again, with a 3-tagger. We were quite surprised that by normalizing surface forms to lemmas in Slovenian language did not improve the result. We actually got a drop in blue score, worse results actually. And in the last set of experiments, these OSM models were added to factor translation system. In the first line, again, is baseline result. In the second line is OSM model over surface form added to the baseline system. We can see that results improved. And to the factor translation based on surface form and MSD tags on both sides, OSM model over surface form and MSD tags were added. And in this case, we obtained the best result overall. And we can see that by adding OSM model to the factor translation where additional factor lemma was used did not improve the final result. In the second table, there are results for Slovenian to English translation, and again we can see that OSM models improve the result in all cases. And to conclude, in our research, 3 different ways for adding morphosyntactic information to phrase-based statistical machine translation were tested for translation between Slovenian and English. Re-ranking the best list did not brought improvement or brought only slight improvement, but factor translation combined with OSM models outperformed baseline system significantly. Larger improvement was obtained for translation from English to Slovenian. If we compare blue score of baseline and the best system, we can see the increase of 2 blue score. It's quite big improvement. And we think that similar results could reasonably be expected for other highly inflected languages as well, when combined with English having simple morphology. Okay. That's all.
About similar work with other Slovenian Slavic languages, for example, Czech language. If there are some similar approaches or other
Yes.
comparison issues.
All these approaches I presented are not new. These approaches were tested for many Slavic languages, and for some languages, actually, this normalization to lemma on the side of highly inflected language improves the results. That's why I pointed out that we were quite surprised that in our case it was not the same. But overall, all these three approaches help in translation for other Slavic languages as well. And there are published researches with these results, yes. It is not a surprise, actually.
Have you tried analyzing the source of errors? Where do the errors lie mainly?
Many errors appear in inflections. Agreement between adjective and noun is very common source, is a very common error in translation. So many errors are actually not so semantic as grammatical.
All
In
right, and you also mentioned that before running below score, you detrocase and
Detokenize, yeah.
Text. How did you do that?
There is a common script for training truecaser, and it is part of a Moses tool, so it was not developed by ourselves. So results would be better if we were evaluate lowercase translation. So this detrocasing adds some errors as well, not just translation.
All right, thank you. Any more questions?